And finally, interpreting coefficients. In front of us here, we've got the 4 models that we built in our backward elimination method. And as we agreed, model number 3 is the best one. It's the best fitted model. And if we were to deliver a model on our project, it would be this one. So let's go ahead and start interpreting coefficients by looking at this model. Here we've got 2 variables, R&D spend and marketing spend. So it's basically how much companies are spending on their research and development and on their marketing. And we've also got the constant, and we're predicting profit. So these coefficients here, these are B1 and B2, what they're telling us is that, so how to interpret them. First of all, you look at the sign. If the sign is positive, that means your variable is correlated with your independent variable is correlated with your dependent variable, meaning that if you change the value of your independent variable, then you can see that the dependent variable will be changing in the same direction. So basically, if you'll be increasing spend on R&D, then your profit will be increasing. If you're increasing spend on marketing, then your profit is also increasing, which makes sense, right? So if you're spending more on research and development, making your product better, then probably your profit should increase eventually as well. Same thing with marketing. The more you spend on marketing, the more you sell, and therefore the profit should also go up. And that's the sign. If the sign is negative, if the sign were negative, then it's the opposite effect. So basically you increase your independent variable and your dependent variable decreases. And now let's look at the magnitude. So here you can see right away that the magnitude is higher for R&D spend and the magnitude is lower for marketing spend. Magnitude is always tricky with regressions. Be careful with magnitude. Sign is kind of, pretty obvious. It's one way or the other. Magnitude can really trip you up. And I can give you an example here. So you might think that, okay, right away, magnitude is greater. So this coefficient for R&D spend is bigger than the marketing spend coefficient. So definitely R&D spend has a bigger impact. Well, what if I tell you that I could easily, without changing anything in the regression, I could easily make this coefficient bigger by a lot, by 1,000 times bigger than R&D spend? Well, it's easy to do. All I have to do is say marketing spend, instead of looking at it in dollars, how about I look at it in a fraction of a cent? So every marketing spend, or let's look at it in cents. So marketing spend, instead of counting it in dollars, let's count it in cents. Right away, because our variable has gone down 100 times, our coefficient will proportionally increase. So it'll go up 100 times. And if I change my data and replace everywhere marketing spend with cents and everything else I will leave the same, then I rerun this model, I guarantee you that the coefficient here will actually become 2.99. So it'll just increase 100 times. Everything else will stay the same. And that way, right away, you'll see, oh, wow, the marketing spend coefficient is greater. So then marketing spend has a bigger impact on your dependent variable profit. And that's a mistake that a lot of beginners make. You should not fall into this trap. Magnitude is a tricky thing. And the way to think about it is always say magnitude in terms of units of the independent variable. So the correct way to analyze this is, even without knowing what they're measured in, maybe this one's measured in thousands of dollars and this one's measured in dollars. I don't know, for instance, although I do know, of course, I've seen the data. But if, say, I don't know, you can still make a conclusion. All you have to say is R&D spend has a greater impact on profit per unit of R&D spend than marketing spend has per unit of marketing spend. And that's all. So basically, even if they're measured in different things, by saying per unit of the underlying variable, you are protecting yourself from that error that they are measured in different things. And moreover, imagine if they're measured, one's measured in dollars, the other one's measured in kilometers or something like that. You can't compare dollars and kilometers, right? But you can always say per unit. And this leads us to the actual interpretation of these variables or these coefficients. What does it mean? So this means 0.79 means that for every unit, if you keep all other variables constant, so you only have one other variable. So if you keep everything else constant, but you are able to adjust R&D spend for in this model, or for a hypothetical company, for every dollar or for every unit of R&D spend that you increase, your profit will increase, according to this model, your profit will increase by 79 cents. That's exactly what this coefficient is saying. And so for every unit that you decrease in your R&D spend, your profit will decrease by 0.79 of a unit of profit. And because R&D spend is measured in dollars and profit is also measured in dollar, that means so for every unit increase in, for every dollar increase in R&D spend, your profit will increase in by 79 cents. So let me just repeat that again. That you are looking at units increase in R&D spend, they translate through this coefficient into units increase in profit. So if your profit was measured in apples, then a $1 increase, a 1 unit increase, this is always going to be true. 1 unit increase in R&D spend will drive a 0.79 unit increase in profit, and of course of the profit units. So let's turn that into dollars and apples. A $1 increase in R&D spend will drive a 0.79 or 80% of an apple increase in profits. So here you're talking about units of R&D spend. In profit, you're talking about units of profit. And this coefficient, it links them together. So as long as you say per unit, you're fine. Once you already know what these variables are measured in, then you can start comparing them if they're on the same scale. And in this case, they are on the same scale because everything's measured in dollars here. And you can say that a $1 increase in R&D spend drives 79 cents increase in profit. A $1 increase in marketing spend drives only 3 cents increase in profit. So basically, if you're the venture capitalist, which companies you're going to invest in? Well, from this model, you're going to decide that you should invest into companies that are spending more on their R&D. There may be lots of reasons behind this, and this is not just a random fact. This could be true in reality because profit is revenue minus expenses. Maybe marketing does drive a lot of revenue to your company, but at the same time, maybe for these specific companies that we're looking at, their expense, the cost of marketing, so the prices that they pay for marketing is so high that the increase in profit, the net increase in profit is actually marginal. So the marketing is eating up a lot of the revenue that it's creating, whereas R&D is creating a lot of revenue, and a lot of it is actually staying in profit, something like that. But we're not worried about that right now. That's more financials. What we're doing is we're delivering a model. So that's how you interpret coefficients. With a linear regression, it's very simple. Just remember about that per unit trick or tip, I guess, because if you forget about that, you can make the wrong conclusions. Otherwise, it's all pretty simple. The last thing that I wanted to mention here is that you can see that every time we run a model, the coefficients change. So what that is telling us is that coefficients actually only talk about the additional effect of every single variable, given that the other variables are already in place. So for instance, in this example, your coefficient of marketing, which is 0.029, means that given that R&D spend is already in your model and it's fixed, then marketing spend adds additional, contributes this additional effect of 0.0299, meaning that if you were to run a different model and take out R&D spend, then the coefficient would be completely different. And that's what we see here, that when we take out marketing, the coefficient for R&D spend is taken out. So that's another thing you should remember about, that coefficients merely portray the additional effect that every single variable brings into the model. Hope you enjoyed this tutorial, and I look forward to seeing you next time. Until then, happy analyzing.